Student friends, in last lecture we have completed topic number 3, that is bipolar junction transistor in all respect, along with the numerical examples which are likely to be asked in the examination. Dear students, today we are going to start with fourth topic of paper number 3, and that is known as field effect transistor. In topic number 3, we have studied bipolar junction transistor. So that was also transistor. This is also transistor. There is a much difference between bipolar junction transistor and also field effect transistor. In B.Sc-I, it is also transistor where there is a transfer of resistor that takes place. But that change in resistance is from low resistance to high resistance. In the field effect transistor, no doubt it is also transistor. But in this, there is a transfer of resistor that takes place from from high to low. In both the cases, there is a transfer of resistor. In B.Sc-I, transfer of resistor taking place from input to output as a low to high. But in field effect transistor, there is a transfer of resistor that takes place from high to low. This device is called as a field effect transistor because in this transistor, output current is controlled by means of a field. Output current is controlled by means of an input field or input voltage. That voltage generates the field, and this generated field controls the output current. That is the reason why it is called as field effect transistor. This field effect transistor has got again a lot of applications. Again, try to remember, field effect transistor is a unipolar device and B.Sc-I is a bipolar device. Unipolar means current is conducted by only one type of charge carriers, that is either electron or holes, but not with both at a time. In B.Sc-I, current is conducted at a time by both the type of charge carriers, that is electrons as well as holes. Such a device we can call it as it is a field effect transistor. Details of such a field effect transistor we are going to study in the topic number 4. Student friends, try to watch and listen the beginning of this particular topic carefully so that it will be easy to understand the rest of the aspects. Again, one thing that remember, this is also a semiconductor device. B.Sc-I is also a semiconductor device. Here further, we are going to discuss our lecture plan, meaning of FET, difference between FET and B.Sc-I, and the classification of FET in today's lecture. Let me proceed further. We are going to put lecture plan in front of you. As far as topic number 4, field effect transistor is being considered. At the beginning, we are introducing this particular topic as already introduced just now. Then we are going to study types of FET, that is classification of FET. After that, we are going to study structure of N-channel FET and also the structure of P-channel FET. But hereafter, we are going to study, we are going to concentrate ourselves only on the N-channel FET, where we are going to cover biasing of N-channel FET. Then we have to study current voltage characteristics of N-channel FET, obviously. After that, we are going to cover FET parameters. What are the different parameters associated with the field effect transistor? Then we are going to study the relation between FET parameters, how these defined FET parameters are related with each other. All these are the aspect of the junction FET. After that, we are going to study a MOSFET, that is the structure of MOSFET, its working and IV characteristics. After that, we are going to cover E-MOSFET, structure of E-MOSFET, its working and also the current voltage characteristics of E-MOSFET. Student friends, at the end of this particular topic, we are going to solve some numerical examples. Friends, again try to remember, in your syllabus, two topics are there on which numerical examples are going to be asked. One of the topic which we already covered, that is a bipolar junction transistor, and second one is the field effect transistor. That's why here also we are going to study at the end of the topic numerical examples, how those examples are going to be solved, what are the formulas which are required for solving the numerical examples. Student friends, this is the plan of our lecture so as to complete the topic number 4, that is field effect transistor. Let me continue further to introduce the field effect transistor under the title known as Introduction. Student friends, FET is a three-terminal, here is a definition basically. FET is a three-terminal, means FET has three terminals. Unipolar device made up of semiconductor in which output current is controlled by input voltage or field. This is the perfect definition of FET. As FET has three terminals, that's why it is called as a three-terminal device. In FET, current is conducted by only one type of the charge carrier, that is either electrons or by holes. That's why it is called as a unipolar device. It is made up of semiconducting material, either silicon or germanium. That's why it is called as a semiconductor device. It has a speciality, and that is in which output current is controlled by input voltage. This input voltage generates a field. At the cost, we can say this field will be used to control the output current. So that's why this FET is also called as field control device or voltage controlled device. As a being, output current is controlled by input field or input voltage, hence called as field effect transistor and is abbreviated as FET. F from field, E from effect and T from transistor, hence it is abbreviated as FET, that is effect. Let us understand the names of three terminals of the FET. Its three terminals are source, gate and drain. These are the three terminals as per definition. As per definition, it is a three terminal device. What are the three terminals? Source, gate and drain. It is a unipolar device because current is conducted by either electrons or holes, not by both at a time. So that's why it is a unipolar device. Such a device, we can call it as it is a field effect transistor. Student friends, let us understand the difference between B.Sc-I and FET. Friends, already we have studied B.Sc-I in the last topic. Now we are going to study the difference between B.Sc-I and the FET. We have defined the FET. For your understanding purpose, again look at B.Sc-I is bipolar junction transistor. Two junctions, current is conducted by two types of the charge carriers, transfer of resistor but from low to high, made up of semiconducting material. It is called as current controlled device. As far as B.Sc-I is being considered, its three terminals are emitter, base and collector. That's all about B.Sc-I. But as far as FET is being considered, it is a field effect transistor. It is also made up of the semiconducting material. It is a three-terminal device, namely source, gate and drain. Current is conducted only by means of one type of charge carriers, that is either electron or holes. Output current is controlled by means of an input voltage or field. That's why it is called as a field effect transistor. Within these two definitions, respectively, for FET and B.Sc-I, we are going to differentiate now both under the title difference between B.Sc-I and FET. So here is a FET, on the other side here is a B.Sc-I. As per whatever you have studied, whatever the knowledge you have about FET now, just now after introduction, we can say FET is voltage or field controlled device. This is because output current is controlled by means of an input voltage or field. In case of B.Sc-I, output current is controlled by input current. So that's why it is called as current controlled device. FET is a unipolar device. Why? In FET, current is conducted either electron or holes. But B.Sc-I is a bipolar device. Why? This is because in B.Sc-I, current is controlled by two types of the polarities, that is by electrons as well as by holes. That's why it is a bipolar device. Friends, FET is less noisy. When FET is operated, noise created will be less. Noise is unwanted signal. What do you mean by noise? It is unwanted signal. So that it generates unwanted signal less. In B.Sc-I, it is more noisy. It is more noisy. In case of FET, it has a high input resistance. FET has a high input resistance, but B.Sc-I has got low input resistance. Why? We studied that in B.Sc-I, input junction is forward biased, and we are aware that when input junction is forward biased, its resistance is less. Friends, as far as FET is being considered, it has a negative temperature coefficient. So negative temperature coefficient means as temperature increases, the resistance of FET decreases. So that's why its temperature coefficient is negative. As far as B.Sc-I is being considered, it has positive temperature coefficient, indicating that Increase in temperature, its resistance increases. It is simple in fabricating IC. ICs can be fabricated by using FATE. And with FATE, to fabricate IC, the process is simple. But it is rather difficult as far as B.Sc is being considered. It is rather difficult to fabricate integrated circuit. IC means integrated circuit. By using integrated circuit technology, it is difficult to fabricate as far as B.Sc is being considered, but FATE can be easily fabricated. The three terminals of the FATE are source, gate and drain. As far as B.Sc is there, its three terminals are emitter, base and collector. In FATE, next one if you want to consider, in FATE, the transfer of resistor that takes place from high to low. In B.Sc, the transfer of resistor that takes place from low to high. Dear students, these are the distinguishing points which are going to be existing between FATE and that of the B.Sc. Let me proceed to classify the FATE. Prior to study the classification of FATE, we will see applications of the FATE. When we are going to study the applications of the FATE, we can say FATE can be used as a switch. That is the first application. Dear students, here are the applications of the FATE. FATE can be used as a switch. It can be used as a high input impedance amplifier. Microwave and integrated circuit applications, FATE is used, especially in microwave devices, and also in the fabrication of IC, field effect transistor is used. Friends, FATE is a linear device. In almost all linear applications, FATE is suitably used. So these are the applications of field effect transistor. By using FATE, you can design your differential amplifier. You can use them in integrated circuit so as to fabricate operational amplifier and so on. All these are the applications of the field effect transistor. Now we are going to study classification of the FATE. How FATEs are classified? Friends, we can call, or we are going to study here the types of FATE. Let me consider this is the FATE, that is field effect transistor. It is a current control device. It has a three terminals, namely source, drain and gate. Output current is controlled by means of an input voltage or field. Such a device, we can call it as it is a field effect transistor in which current is conducted by only one type of charge carriers, either holes or by means of an electrons. This FATE is classified mainly into two types. One is a Z FATE, that is a junction FATE. Second one is MOSFET. MOSFET means metal oxide semiconductor field effect transistor. One is JFET, junction field effect transistor. Second one is MOSFET, that is metal oxide semiconductor field effect transistor. Student friends, this junction field effect transistor is classified again into two types. One is the N channel JFET. It is a type of J-FET, but it is a channel for conduction of the FET is of N type. Here current is conducted only by means of an negatively charged particles, that is by means of an electron. Such a junction FET, we can call it as it is the N-channel FET. Second type of junction FET is P-channel FET. Here the channel is of P type. Means here current is conducted only by means of positively charged carriers, that is by means of holes. Hence this FET we can call it as it is a P-channel junction FET. Junction FETs are two types. One is N-channel FET, second one is P-channel junction FET. Let us go to the MOSFET. That is metal oxide semiconductor field effect transistor. This MOSFET is again divided into two types. One is E-MOSFET and second one is a D-MOSFET. E-MOSFET is called as enhanced metal oxide semiconductor field effect transistor. We are going to see details of all those things afterwards. E for enhance, M for metal, O for oxide, S for semiconductor FET field effect transistor. Second one is D-MOSFET. It is a depletion enhanced metal oxide semiconductor field effect transistor. It is a D-MOSFET. Dear students, E-MOSFET is further divided into three types. One is a P-MOSFET, that is positive enhanced metal oxide field effect transistor. Second one is a N-MOSFET, negative metal oxide field effect transistor, and third one is C-MOSFET, that is a complementary metal oxide semiconductor field effect transistor. C-MOSFET, it is a combination of P-MOSFET and N-MOSFET. Analogous to this, D-MOSFET is again classified into three types, that is positive depletion enhanced metal oxide semiconductor field effect transistor, negative depletion metal oxide semiconductor field effect transistor, and last one is complementary depletion enhanced metal oxide semiconductor field effect transistor. Dear students, this is how one can classify the field effect transistor into the different types. To summarize, we can say FET is broadly classified into two types. One is J-FET and MOSFET. J-FET is further classified into two types. One is N-channel FET, second one is P-channel FET. Analogous to that, MOSFET is classified into again two types. One is E-MOSFET, second one is a D-MOSFET. Each MOSFET are further classified into PMOS, NMOS and CMOS field effect transistor. At the outset, we can say in today's lecture we have studied the meaning of FET, why it is called so, terminals of the FET, difference between FET and B.Sc-I, applications of B.Sc-I, so applications of FET, and at last we have studied the classification of FET. Student friends, that's all about today's lecture. Next time we are going to study the structure of N-channel junction FET and also the P-channel junction FET.